Alright, this is the first video for the moles to mass stoichiometry assignment. For this assignment, we're going to continue to use our graphic organizer we started using in the previous lesson. Just as a reminder, it's kind of reminding us the different conversions we know that we've done over the past month or so. So when you're going between moles and particles, we have to use Avogadro's number in the conversion factor. When you go from moles to mass, you have to use the molar mass in the conversion factor. And when you go between moles and moles, we're using mole ratios in the conversion factor. You can go back and look at some previous videos where we do examples of each of those types of problems. We're at multi-step problems now, and so up at the top, I've already put the balanced chemical equation for the first problem that you can see in the assignment document. We've got 2 sodium hydroxide reacting with a sulfuric acid to produce water and sodium sulfate. If you guys remember back to your reaction types, that would be both double replacement and neutralization, because we have an acid, a base, a salt, and water. But the question is asking how many grams of sodium sulfate will be formed if you start with 2 moles of sodium hydroxide and excess sulfuric acid. So, when you're doing these problems, let's answer a few questions. Let's figure out what do we know and what do we want to know. This is another way to break down these problems. These problems today are actually very similar to the ones in the last lesson. So you could actually give them a shot before I even go over it and see if you can get it right just by using this flow chart. But I'm going to start here, we're going to use the flow chart, and then we're going to solve the problem. Problem's actually written out in the assignment document, so if you haven't already, go and pull up the practice moles to mass stoichiometry assignment. Anyway, so what do we know? If we look at the question, it tells us that we're starting off with 2 moles of sodium hydroxide. So we know we have 2 moles of sodium hydroxide. Remember that OH is your polyatomic ion hydroxide. This is why it's important to memorize the polyatomic ions, because that's how we name a lot of our ionic compounds. So when you're trying to answer the question, what do we know, look in the problem for the numbers they give you. That usually is where you can find the information that you already know. What do we want to know? To find that, we look in our problem and we look at it for the question word. So the question word here is how many grams of sodium sulfate. So we want to know how many grams of sodium sulfate this makes. So, put this in another way of looking at it. We have 2 moles of sodium hydroxide. We want to know when we do this reaction, when we use 2 moles of sodium hydroxide, how much sodium sulfate do we get out in grams? So, we're going to go over here now to this graphic organizer. We're going to take these questions and figure out where we're going. So, what do we want to know? Sorry, what do we know? 2 moles of sodium hydroxide? Well, that's where we're starting. So, that unit is moles of sodium hydroxide, and I'm going to assign it this moles over here. We can actually, remember, we can separate sides to go between 2 different substances like we are here. We're going from sodium hydroxide to sodium sulfate. We need to go convert moles from one set of moles to another set of moles. That's how you convert between substances. So I'm going to assign this side what we're starting with. What do we know? Sodium hydroxide. And I'm going to assign this side what we're trying to find. Na2SO4. So we are starting with 2 moles of sodium hydroxide. And we want to know how many grams of Na2SO4. So this side's Na2SO4, and grams is mass. So to get from moles of sodium hydroxide to mass or grams of sodium sulfate, we need to see what arrows take us there. We see that arrows will take us from moles to moles, and then from moles down to mass. And so because we're crossing 1 arrow, 2 arrows, that's going to be 2 conversion factors. It's a 2-step problem. So if we start writing out our problem, let's put what we know as our starting number. We're trying to convert that. So we know we have 2 moles sodium hydroxide. And we're going to multiply by 2 conversion factors, one for each arrow. We're going to start by filling in the conversion factor for this first arrow, going from moles of sodium hydroxide to moles of sodium sulfate. Now, whenever we go between moles of one substance and moles of another, we need to use a mole ratio. In mole ratios, we get the numbers from our balanced chemical equation. So we're starting off in moles of sodium hydroxide. We want those 2 units to cancel out. So we'll put moles NaOH on the bottom. We're going from moles of sodium hydroxide to moles of sodium sulfate. So we'll put moles of sodium sulfate on top. Now, as I said, it's a mole ratio. We have moles on both sides of that conversion factor. We need to look in the balanced chemical equation at the coefficients to find the numbers. So for sodium hydroxide, we find sodium hydroxide, which is over here, and its coefficient, when it's balanced, is a 2. So we'll put a 2 with sodium hydroxide. For sodium sulfate, we're going to look for sodium sulfate. We find it over here. It doesn't have a coefficient written there. That means it's a 1. Remember, if you don't have a coefficient written somewhere, it's implied to be 1. So that is our first conversion factor. That gets us from here to here. Now to go from moles of sodium sulfate down to mass of sodium sulfate, because that's what we're looking for at the end of this, we've got another conversion factor. So we know that moles of sodium sulfate has to go on the bottom, because we don't want moles of sodium sulfate. We want grams of sodium sulfate. So we're going to put that on the bottom and convert away from that to something else. And because we're going from moles to mass, the unit for mass is grams, and our substance will still be sodium sulfate. Now we need to figure out what numbers go in these blanks. To find that out, we need to look up the molar mass for sodium sulfate. And as usual, I will actually work this out for you. All right. So, the molar mass of sodium sulfate we need to find the mass of, we have sodium, we have 2 sodiums, we need the mass of 2 sodiums, 1 sulfur, and 4 oxygens. Again, you look at the periodic table to find out the masses of each of these. I believe sodium is 22.99. I believe that's 45.98. We will double check. 45.98. Sulfur, I don't remember its atomic mass right now. Sulfur, atomic mass. You look on a periodic table, and we will go ahead and round that to 32.07. So 1 times 32.07 is still 32.07. And we've got 4 oxygens. Each oxygen is 16. So that brings us to a total of 64 for oxygen. Now, to get the total mass of all of these, we need to add these up together. So that gives us 5, another 12, 14. Let me double check that in a calculator. Okay, checks out. So that is the molar mass of sodium sulfate. So this is a small mini problem we have to do on the way to our answer for the big problem here. That's how many grams are in 1 mole. So we will always put this number with grams when we're doing molar mass conversions. So that's 142.05, and we will always put a 1 with moles when we're doing molar mass conversions. The only time you have to look to see what number you'll use with moles is when you're doing a mole ratio. That's the only time where it might not be 1, and you have to look at your balanced chemical equation. That's only when you're going from moles to moles. When you're going from moles to moles, look in the balanced chemical equation. When you're going from moles to anything else, 1 always goes with moles. All right. So now we just need to work out the problem. Let's see if anything cancels out right away. We've got moles of sodium hydroxide. That cancels out with moles of sodium hydroxide. That's why we set up the problem like that. We have moles of sodium sulfate. They cancel out with moles of sodium sulfate. That's why we set up the problem like that. All right. I'm going to give us some more room. let's clean this up a bit, get rid of all the stuff we just canceled out, and get rid of the ones, because the ones don't do anything to the math. So we've got 2. Let's see, that canceled out, times 1 is still itself, and then that canceled out, times 142.05, we still have grams of sodium sulfate. All right, that's the numerator. Let's look at the denominator. So look at the bottom. We've got a 2 in the denominator. Moles of sodium hydroxide canceled out. 1 is still itself, and moles of sodium sulfate canceled out. So I think the only thing on the bottom is a 2. Now, I will actually take this out from under here just because I like putting the numbers in a fraction and keeping the units off to the side. You don't have to. You can write it out like this. It's the same thing either way. But if we look at this, we see we have a 2 in the numerator and a 2 in the denominator, and there's no division, there's no addition or subtraction happening in the denominator. So we can actually cancel these out. So 2 divided by 2 is 1, so they cancel each other out, and we are left with 142.05 grams of sodium sulfate as our answer. Now, as with all these other ones, we need to actually check the sig figs. So we look back at the beginning, and 2, that is 1 sig fig. So our answer only gets 1 sig fig, and this is where it gets kind of weird and tricky. So we start from the left and we find our first sig fig. Well, our first sig fig is here. That's that 1 in the hundredths place. We only get 1 sig fig, so we actually have to round to the hundredths place. So we're going to round 142.05 to the nearest 100, and the nearest 100 is 100. So, because there's no decimal here, those zeros right here are trailing zeros without a decimal. They are not significant. The only significant digit in our answer is that 1. These zeros just hold that 1 in that hundredths place. So we're rounding this to this. And that's because the 2 only has 1 sig fig. It's not a very precise measurement. If they got exactly 2, like 2.000, you might get some more digits in here and it won't look as off as like just rounding it to 100. But because that first measurement was imprecise, our answer won't be very precise either. So we actually have to round it to 100 grams of sodium sulfate. So, give the next couple a shot. Again, this should be in a playlist, so there should be videos for each of the problems. I encourage you to attempt them before watching the video, but I'm pausing when you think you got it before seeing the answer. I hope you all are well, and if you need, you'll see me in another video.